Hello students, today we will discuss about the free body diagram. Now let me define first the free body diagram. The diagram of the body in which the body under consideration is freed from all the contact surfaces and all the forces acting on it, including reactions at the contact surfaces, are drawn is called a free body diagram. So let me explain this one. Free body means the body which has been freed from all the contact surfaces. That means suppose a ball is kept on a table. If you want to draw the free body of the ball, then I have to draw only the ball, not the table. So this is free body. Now free body diagram means I have to show all the forces acting on the object, that is including the reactions. Now let me explain the reactions. So suppose a block is kept on a table. This is a block kept on a table and the weight of the block is W. Now the block is under the gravitational force, but it is not falling on the floor because this table is not allowing the block to fall on the ground. That means it is resisting the gravitational force acting on the block. That resisting force is known as the reaction or normal reaction. So what are the forces acting on this block? W is acting vertically downwards and the reaction force is acting vertically upwards. So two forces are acting here which is to be shown in the free body diagram with the object. So now the object, that means block, is drawn here. This is the free body diagram of this block. So the block is drawn here, then vertically downward force W is acting and the reactive force, which is normal to the horizontal, is acting vertically upward. So this is the free body diagram of this is the mechanical system. So this is the simplest example of free body diagram. Now let us look another example. This is a roller which is hanging by a string from this wall which is hanging by the string from this wall, and the string is mounted solidly here and the ball is freely hanging. The roller is freely hanging. So now let us see what are the forces acting on this ball. We have to draw the free body diagram of this ball. Now this ball has a tendency to move in the direction of the gravitational force. So its weight W will act vertically downward. And since there is no horizontal contact surface here, so normal reactions at this end will not be there. Now this ball has a tendency to go in the left side, but the wall is giving the resistance. So normal reaction will be at this contact point. That normal reactions are in this direction. So W is acting vertically downward and the normal reaction at this point is horizontally in the downward, in the right direction. And since the string is and the string is attached with this ball, with this roller, so it is not allowing the roller to fall. So there is a tension in the string, the tension in this direction obviously. So there is a tension T has been shown in this direction. So these are the three forces acting on this ball. W is the vertically downward. Normal reaction at this point is in the horizontal direction, in the right direction, and tension in the string in this direction. So this is the free body diagram of this roller. Now let us take an example of the cantilever beam with the loads on this beam. Now this is a cantilever beam. One end is rigidly attached with a wall, and three forces are acting here: F1, F2 and F3. F1 is vertically downward, F2 is vertically downward, and F3 downward, but with some angle with the vertical. Now let us see what will be the free body diagram of this cantilever beam. So first let us draw the cantilever beam, not the contact surfaces, only the beam is drawn here. Now the three forces are drawn: F1, F2 and F3. Now the weight of the beam has been shown here, W, vertically downward. So 1, 2, 3 and 4 forces. Now since the beam is rigidly fitted with the wall, so the reactions will be only at this end. On the contact points here, the reactions will be there only, because there is no other way to produce a reaction. Now if we so now let us see what are the vertical forces acting downward. F1 is one force, F2 is another force, and W is the another three forces directly acting vertically downward. And this F3 force is also acting downwards, but it is not vertically. So we have to resolve these forces into two components. One is vertically downward and another is horizontally right, in the right direction. So the vertical forces are there, are then F1 plus F2 plus W plus the vertical component of F3. So the reaction must be equal to that total downward force, and that is equal to Fv, which is acting upward at this contact point. That means F1 plus F2 plus W plus the vertical component of F3 is equal to Fv. Okay, F1 plus F2 plus W, F1 plus F2 plus W plus the vertical component of F3 is equal to the Fw. So the vertical forces are drawn. Now let us see what about the horizontal forces. the horizontal component of F3 is acting in this direction. That means this horizontal component of F3 has a tendency to pull out the beam from the wall, but such is not happening because there is a reactive force in the opposite direction generated in the wall, and that is equal to FH. So FH is equal to the horizontal component of F3. Clear? Horizontal component of F3, which has a tendency to pull out the beam from the wall, is being resisted by the reactive force FH produced at the contact point. So FH is a reactive force. So FV and FH both are, this is vertical reactive force and this is horizontal reactive force. Now you see that this beam, on this beam there are 4 vertical forces are acting: F1, F2, W and vertical component of F3. So this beam has a tendency to rotate in this direction, That means a moment has been created by these 4 forces in the clockwise direction. But since it is rigidly fitted with the wall, that means wall is not allowing to rotate the beam in this direction. So that means an opposite movement has been created in the anti-clockwise direction. That means this beam has a tendency to rotate about this point in this direction. So to prevent this rotation, the wall has produced a counter movement in the anti-clockwise direction, so that the movement of the beam doesn't happen. So this is the reactive moment force. This is the reactive moment force has been generated here. So therefore we have seen that reactive forces are vertical FB and horizontal FH and the anti-clockwise moment M. So these are all shown, all the forces F1, F2, F3 and W, and the reactive forces FV, FH and M has been shown in this figure. So this is the free body diagram of this mechanical system. Let us take some other examples. The first one is two solid spherical ball is kept within a cylinder. This is the cylinder. Now these balls have weight W1 and W2. Sphere 1 has the weight W1 and sphere 2 has the weight of W2, and this ball has touched this wall at point C and this wall at point A, and the bottom of the cylinder at point B, and the two balls has touched each other at point D. So this is the mechanical system. We have to draw the free body diagram of these two balls, two spheres, W1, number 1 and number 2. So first you see, let us draw the free body diagram of this ball. Now you see what are the forces acting on this. The forces acting are W1, vertically downward. There are no other forces acting on this ball. But at this point a reactive force RC, which is perpendicular to this vertical line, and it is acting in the left direction because the ball has a tendency to move in the right direction. So this one is giving the resistive force in the left direction. So our reactive force at point C is the RC in the left direction horizontally, and again this ball has a tendency to move in the left side, but the ball is not allowing, so it is giving a resistive force in the right direction horizontally. So reactive force at A is RA, acting in the right direction horizontally. So there are no other forces acting. Sorry, not A. I am very sorry. I have omitted this one, D. The the reactive force is acting on the sphere 1 is at C, that is RC, and the reactive force acting on at point D, not A. A is about the 2, the number 1 we are considering now. So this ball has touched at this point D, and this ball is giving pressure on this ball, so this sphere is also giving force to this sphere 1. So the sphere 1 is experiencing a reactive force in this direction, which is perpendicular to the tangent at this point, So this is the direction of the reactive force RD. So the free body diagram of sphere 1 is complete. Force acting is W1 and the reactive forces are RC and RD. Now let us go to the second sphere. Now this is the weight W2. So W2 is acting vertically downward, and since it has touched the bottom surface of the cylinder, so which is giving the reactive force vertically upward. So at point B the reactive force is RB, vertically upward. And similarly in the case of C, at the point A there is a reactive force which is perpendicular to the tangent at this point is RA. So RA is shown, which is acting horizontally right direction. So these are the free body diagram of this mechanical system. Now in this example, this is the mechanical system. This is an wall and AB is a beam. I have written here, AB is a beam, and the beam is fixed with the wall by this string CD. AB is the beam and CD is the string which holds the beam AB with this wall. And at the end of the beam AB, a weight is hanging whose weight is W, and the beam is hinged here. The string is fixed here and the beam is hinged here. Hinged means it can rotate in this direction. So it is hinged here. Now you see what are the forces acting here. First, the W is the force acting vertically downward at this end at the point B on the beam, on this beam. So I have shown the W. Now the string has a tendency, the string is holding this beam to prevent the rotation of the beam in this direction. So there is a tension in the string. So tension T is drawn. Now at this point, there is a reactive force. There is a reactive force because due to this weight, this beam has a tendency to go inside, but the wall is not allowing that one. So it is giving some resistance. Let me draw, that is RA, reactive force RA, but the direction of RA will be what? Now you see, since this is in equilibrium condition and the three forces are acting on this, so these three forces must coincide each other. Now if I extend the line of action of this force T, if we extend the line of action of the force T in this direction, it will cut this vertical line at this point. And if I join this point, if I join this point with A, that will be the direction of the reactive force RA, because these three forces are meeting at this point, since this system, mechanical system, in equilibrium condition. So this will be the direction of the reactive force RA.